Well, I think I'll go ahead and get started with the introductory remarks, and we may have some others joining us in the meantime. I have several minutes after the hour. So first of all, let me welcome everyone to today's HESI webinar on Assessing and Comparing Chemicals for Sustainable Alternatives, Challenges and Strategies. We have participants from around the world, especially in Asia and from the US, so that is why we've scheduled it at this time. And thank you for all joining us at this time today. And I also want to thank Ayako Takai, who's HESI's Asia consultant, as well as Cyril Pettit, HESI's Executive Director, for also making this webinar possible today. And just want to let you know that this webinar is part of a series that HESI's been conducting for several years, and you can view past webinar recordings on our website, as well as this one once we've posted it shortly. And our website is www.hesiglobal.org. And my name is Jennifer Young-Tenier. I am a Scientific Program Manager at HESI, and I'm also the manager for HESI's Committee on Sustainable Chemical Alternatives, which is the topic for today's webinar. The presentation that Pam Spencer will be giving is going to describe the science of that topic, as well as illustrate some of the work that the committee has been conducting over the past years. And our speaker today is Dr. Pam Spencer from the Dow Chemical Company. Let me introduce Pam with a short bio. Pam is the Product Sustainability Consulting Director for Dow Chemical's Toxicology, Environmental Research, and Consulting function. She's worked with Dow for 28 years. Over the last 10 years, she's emerged as a sustainability and green chemistry expert, leading a variety of efforts externally and internally to advance the awareness of toxicology's role in sustainable product selection and development. She's the co-chair for HESI's Sustainable Chemical Alternatives Committee and also serves as a toxicology expert for the American Chemical Society's SciMind webinar training series on toxicology for chemists. In addition to sustainability and green chemistry, Pam's research focus has also included many aspects of genetic toxicology testing and rapid screening models for carcinogenicity. She received her PhD in toxicology at the University of Michigan and is a diplomat of the American Board of Toxicology. So now I'm going to turn the controls over to Pam for her presentation. Following her talk, we'll have some time for questions. And if anyone's unable to connect via the webinar, you should have received the slides through an email message today. That will help you. You can just follow along with those slides if you're unable to connect. Also, I'll remind you to please mute your phones during the presentation portion. And if you don't have a mute button, you can press *6 to mute and to unmute your phone. So with that, let me turn the controls over to Pam.
Okay, thank you, Jennifer, and good morning and good evening to those on the phone. I'm really delighted to have this opportunity to share this information with you tonight. So let me bring it up and first make sure that everybody can see my screen. Jen, maybe you can tell me if you're seeing it, then I know.
I'm seeing it.
Okay, great. I'll put it in. And I know that there are a couple of individuals who weren't able to connect to the webinar, so I'll try to give a cue when I'm switching slides so that you can follow along easier. So what I want to cover in this webinar today is really talk about why focus on alternative selection, why do we even care, and go a little bit then into what the HESI Sustainable Chemical Alternatives Committee history is and what they've been trying to do, what some of those key opportunities that have been identified through this, as well as key considerations. A little background noise if we could mute. And then discuss recommendations and such. I have Q&A. Is it possible to mute, Jen, from where you're at? Can you mute all the participants? Okay, so alternative assessments, just so that we're all starting from the same foundation, is a process that helps to guide selection, and it's a process that can help.
All participants are now in listen-only mode. All participants are now in interactive talk mode.
Sorry, if I mute everyone, then I mute you also, Pam.
Oh, no. All right. Well, we'll have to just go along, and hopefully the background noise will stop. I'll try to speak louder. So alternatives assessment, then, is really a process that can be used that can help an individual weigh attributes from one chemical to another to make choices about what would be the better alternative. Typically, this is used when there's chemicals or technologies of high concern that there's a desire to replace. So why do we even care about the need to look for alternatives? Well, there is increasingly more pressure for us to do this. On the regulatory front, where there are efforts to replace chemicals of concern, and you have examples like REACH authorization, California Consumer Products Regulation, which was recently promulgated and is starting to look at their product categories, and then elements that are being discussed as part of TSCA reform here in the United States. Corporate sustainability initiatives could also trigger the need to look at alternatives as they're looking at targets for greenhouse gas reduction, energy conservation, or raw material preservation, or reduced hazard options. And then more recently, and what's becoming even more prevalent, are customer and consumer drivers. And so there are a number of retailers now who have taken it on themselves to develop lists of chemicals that are banned from being in products on their shelves, and then also eco-label certifications as you're trying to identify and gain certification for what might be greener or more sustainable alternatives. So these are all drivers that are really fueling the need to have methods that are consistent to look for suitable alternatives. Now, the HESI Sustainable Alternatives Committee was formed about 2 years ago with the mission to really evaluate and identify key elements and criteria, and then to try to understand where tools and guidance were needed to help drive better selection of sustainable alternatives. And the main objective is really to look at practical problem-driven guidance, so it's really going to work in the way that the whole process for how alternatives are assessed are managed. And we held a workshop in February of 2013 to bring a number of key stakeholders, both from industry, academia, and government, as well as NGO, to talk about what some of those needs were, where those gaps were, and what path forward we should take going forward. And this really became a committee status in January of this year. This just gives you a flavor of the committee participants in 2014, and as I said, you can see that we have many different diverse groups that are participating today, from regulatory agencies, academia, and industry. And the committee was really formed with some very early project objectives, because this was the first project ever taken on by HESI that was so broad and multidisciplinary. So originally the intent was to build an understanding of the existing approaches that are out there. Let's see what's there. Let's look for strengths and weaknesses and any gaps in those current approaches, and then try to identify what the emerging needs and challenges were for the future. And based on those key learnings, then to focus on developing and publishing recommendations that could improve the process or deliver more information where it was needed as the process was being carried out. So in looking at the frameworks that were out there, the characteristics that they seemed to all contain were that they were really frameworks designed to guide to guide the assessors through the process, and typically it would address general principles, but not really give details on how to go about and conduct the comparisons and reach conclusions. And what you can see is part of the general principles that are often included in the framework, there's a pretty heavy emphasis on hazard. So attributes, while technical performance, cost, some life cycle considerations, or even social justice aspects might be included in the frameworks, hazard was very heavily emphasized. And if you look at a couple of examples that I have here, this is the UBA Guide on Sustainable Chemicals, and you can see their criteria, evaluation, and options to act. And you can see that what they're looking at as potential triggers for why one would want to conduct an alternative assessment were things like dangerous properties. The substance might be on a list, human toxicity, dangerous to the environment, and then we have things like greenhouse gas, resource use, or origin of raw materials. And these assessing these attributes would then lead to some conclusion that would either dictate that you might consider substitution, you might consider substitution with risk management, maybe you limit to specific use criteria, substitution with design for increasing energy or increasing material efficiency, or maybe request standards from a supplier or change sourcing. All might be reasons to take actions to implement the use of an alternative. Others would say perhaps maybe no need for action if things came out green, or maybe you just need more information and you have to go to a gathering information mode. But in the framework itself, it does not tell you what tools you should use, how you should look at quality of the data, what to do with gaps, or how to weigh between these different attributes. So it's just a high-level framework. Again, if you look at another one, the Lowell Alternative Assessment Framework, again, they have a comparative assessment where you can look at existing chemicals, materials, or products, characterize what the end uses and functions are, identify if there are alternatives, and then again you're doing the evaluate and compare across the number of attributes, things like human health and the environment, social justice, economic feasibility, technical feasibility. The difference here is that with the Lowell framework is that they're looking at a design assessment. So they're saying, okay, what if we don't have an alternative? Then how do we go about looking at assessing a new material? And again, while the framework is there and it gives you the general concept of the steps that one should take as they're thinking about how to assess an alternative, the real details about what tools and what data and what to do with gaps and the weighting, again, is largely absent. Also under consideration was the fact that we needed to think about avoiding regrettable substitutions. And this is really a case where maybe we make a change in one area, let's say a consumer product, we're looking at an alternative, and we end up maybe transferring the risk to another part of the value chain. Maybe we create more waste, or we create a more hazardous situation for our manufacturing facility and our workers. So it's really important to understand not just the chemicals that you're comparing in the targeted application, but what is the impact throughout the value chain so that we can avoid regrettable substitutions. And an example that was presented at a recent conference that I was at actually had to do with a large effort to replace consumer cleaning products in schools and public buildings in one of our states here in the United States. And as a result of replacing those with green cleaners, they're now starting to see an increase in worker OSHA recordables. So somehow it appears that the green cleaners that they're now using have some way altered their cleaning practices, and now the workers are getting injured. So it's important that we understand what the impact is as we're comparing and looking at replacements. So the HESI committee decided that the overarching issues or opportunities then were really to provide more detailed guidance that could actually help a person that was going to conduct the alternative assessment get through that process, a more step-by-step detailed approach. In that it would be somewhere between a tools and a framework, because there's already a lot of tools out there, and one of the things that we don't want to do is reinvent things that are already out there. And then to be cognizant that it had to address different needs across the supply chain, as well as to help facilitate new product development. So as a part of understanding new product development, we took some time to try to understand what are the characteristics of new product development. And the first thing to understand is that really developing new molecules or replacing existing ones is very expensive. And when you're looking at alternatives, it has to be technologically feasible, it has to deliver the same or better value at the same cost, and it has to perform at the same level or better. It also has to have an improved profile for health and environmental issues. And then somehow we have to account for economic and social considerations that are also part of this complex assessment, and then have the potential to have lasting change, because what we don't want to do is to select an alternative that itself might be in the future deselected or restricted. So a case in point, if you look just as an example of an agricultural product, that development for that product is very resource intensive. It takes 10 years and $250 million to research, develop, and register just one new ag product. And it's very tightly regulated. 1 in 139,000 chemicals really actually ever make it from the lab to the field. And then the product itself undergoes more than 100 regulatory studies to support the health and safety and environmental assessment. So it's very important that we get it right the first time, or we've wasted considerable resources, time, and money. So an alternative assessment has to be able to help guide the right choice. It also has to fit in with the way industry develops or takes a product to market. And so we did some considerable time trying to understand how new products are developed. And many industries use what's called a stage gate concept. And in the stage gate concept, what you're doing is you usually start out with an idea, you're shaping it, you're doing a little bit more analysis and validation, and finally it gets into development, implementation, and makes it to market. And the important thing is to note is that as you get down this stage gate process, it gets more and more heavily invested in cost, time, and resources. So we need to have something that can be disciplined but flexible, that fits into the stage gate process. We want to be able to understand as much as we can, as early as we can, while we can still help the innovator make choices. So really what we'd like to see is that we would fail fast, succeed early, and target really 2 phases of R&D where we quickly eliminate the poor candidates early and increase the probability of launch late, keeping in mind that we have to have equal performance. So these are just some of the concepts that have to be taken into consideration when we're talking about new product development and we're thinking about alternatives. At what point are we going to start assessing alternatives? We really can't wait till the very end when the product is ready for launch to do that, because by then it's far too late. So what we need to do is make sure that the guidance will help drive early decisions early for innovation. So something that can inform molecular design, that might help with selection, inform any testing or data needs, and I want you to understand that this goes beyond just toxicity and hazard information, can help with pre-manufacturing, optimizing formulations, maybe even take into consideration exposure assessment, and by doing all of these, be able to save time and money, because when we do finally get to the end, we're launching more sustainable alternatives. So an alternative assessment can work at the end when you have existing products and you want to make comparisons, but oftentimes you're not going to have a replacement, and it's going to need to be able to fit into a process that's going to drive innovation. So this meant that we had to have additional considerations for guidance. There had to be some mechanism for us to understand early awareness. For toxicity, there's a lot of information out there that can help to help guide design choices. But we also need to consider other things like LCLA-like data and some of the sustainability metrics. And so the data that's generated has to be useful to help inform the molecular design, drive wiser decisions, and then inform maybe the regulatory information that's needed. And it needs to be rapid and relatively inexpensive in the early stages. So taking all of that information into consideration, there were 3 subgroups that were formed as part of the HESI committee. The first subgroup was going to look at attributes and tools. And again, as I said, there's an awful lot known about how to assess hazard, but it's also important to go beyond hazard and start to say, how do we gather information on life cycle impact, exposure, risk, performance, social responsibilities, these other things that are a little bit more nebulous and harder to assess. And then identify where there are tools or where new tools are needed to help prioritize some of these areas throughout the stage gate process. Another group was looking at decision making and weighing, and this is really talking again about what becomes more important, what attributes are going to really drive the decision making, and what are those best practices going to be for weighing disparate attributes. And then finally, a third subgroup was looking at how do we address data gaps, and when there's data gaps, what are the solutions for addressing those missing data gaps. So subgroup 1 looked at a number of existing alternative assessment frameworks, and the list is here. It's a little hard to see, but if you have the slides, and I apologize, I haven't been giving you the slide number, but I'm on slide 19. But these are the alternative assessment frameworks that we looked at and some of the characteristics, and then what the attributes are that they were actually looking at. And all of them, in some way, shape, or form, is assessing the hazard and exposure. Some include life cycle, a few social, and a few more that are looking at cost performance. So based on that, subgroup 3 started to say, how can we start to create a logical set of guidance documents that can build off of the alternative assessment frameworks that are there? And what is being done now is to really look at these attributes across the product life cycle stage and begin to catalog what options are available to make assessments at those particular stages in the product development. And again, as I said, for hazards, this is very well characterized. And in fact, the new tools that are emerging within the toxicology community today are making this a very feasible option. And as an example, I mean, in our own company, we've started to categorize what tools can be used where and what their benefits are for using them. So we have different cheminformatic tools that we can apply early in product development to do estimations, to look for analogs with data that we can read across to, or just to do widespread data mining to see what's out there. We also have started to categorize an expanded list of search tools, and there are many activities going on in this area right now. OECD is putting together an alternative assessment toolbox that has a lot of these hazard assessment tools. The IC2 out in Washington also has a catalog of these tools. And then in addition to the computational tools, there are also a number of in silico assays that are starting to emerge that are used at a little bit later stage of product development to help validate what was seen in the earlier assessments. So the question is, how can we build on what's being done already in the hazard assessment realm to be able to have similar tools and guidance for things like technical performance, exposure, risk, life cycle, and some of these sustainability elements, because these are the ones that, again, I said are more nebulous, and we just don't seem to have those tools available today to be able to help guide decisions for those attributes. So this is all still in progress. With decision making, understanding some of the lessons from alternative assessments that have already been done. There are a number of publications out there on multi-criteria decision analysis, hazard-based alternative assessments using tools like green screen or the design for the environment. And then, again, looking at what we learned from just the way we are looking at things through our industry stage gate. One thing that has emerged as being very clear is that an alternative assessment process is multidimensional and very, very complex. And you simply can't address all of the needs for an alternative assessment with just technical approaches. We've got to go beyond that. So we recognize that we need a structure that really promotes a decision-making process to facilitate how choices and decisions are made rather than trade-offs or cost-benefit analysis. And what do I mean by that? What I mean is that we have to start to have more interactions and more synergies among all of the stakeholders, regulatory, industry, and public, and recognizing that each one of those stakeholders are going to come with their own preferences concerning risk, economics, and whatever sustainability attributes there are, and that these are going to vary. So we need some mechanism then to be able to determine whose weights matter, you know, public, private, societal values, regulatory goals, because those are the tough decisions that are going to have to be made, and they're going to have to be made in a very transparent way where we can be clear about how that weighting was done and what the rationale was. Today, many choices are made simply based on hazard, and that's really not going to be enough as we go through and start to implement alternative assessments on a larger scale. So the point is comparing alternatives is very complex. It requires expertise across different disciplines, across the product life cycle. We have to think about these other areas like technical performance, economics, LCA, and it's going to require different tools. There's not going to be one magic bullet or one magic program. It really is going to take a consolidated, integrated effort of experts across the varying areas in a transparent way to really make decisions and choices. And so that's really the challenge. And as I said, there's been a lot of focus on hazard identification and making low hazard materials, a little bit of focus on maybe LCA and you know, energy conservation. But in the end, we have to start to take in all of these factors as well as what stakeholders' opinions are and how they play into that weighting. So I'll just say that the devil is in the details. You know, how do you determine and compare what's most appropriate for the alternative assessment? How do you weigh one chemical against the other, especially if we're talking about new product development? What's the minimum base data set? We kind of understand that for, again, like I said, hazard, but there are other areas that that's going to have to be looked at and some decisions made. And are there scenarios where maybe we can even eliminate the need for data? How are we going to fill data gaps? What are the best practices going to be for doing that? And what are the utility of emerging tools and technologies? And then again, how do you deal with, I say trade-offs and conflicting results, but it can also be with different preferences for risk, and how are you going to weight to decide which one is going to carry more weight in the assessment. So again, weighting is very important, and depending on how you weight that, you can come up with different conclusions. So a lot more questions than answers. I hope those of you that were thinking you were coming to the webinar to get the answer for all of this aren't disappointed, but the point is there's still an awful lot of work to do, and we're really just scratching the surface today. So with regard to recommendations in emerging needs, definitely more details are needed. There's general agreement that we have got to move beyond hazard, that there has to be a consideration of other things like LCA, risk exposure, cost, performance, social responsibility. All of those are important because those are going to play to different sectors who have different goals, and we have to start to bring those to the table. More standardization is needed with current methodologies. Again, the frameworks that are out there leave a lot to be desired with how to go about the implementation, and it would be good to have a little bit more solid guidance around that. Flexibility in the tools and methods that can align with the stage gate of product development, and then a clear process for handling data gaps and weighing multiple attributes, including the societal criteria. So I think it's important to recognize that it really is going to take increased collaboration across expertise. I do think that we tend to get comfortable and work in our own silos, and this is really an area that's going to take building partnerships and working together if we're going to really make the best choices. So we do need a pool of expertise across academia, government, NGOs, and industry. And this is really what the HESI Sustainable Chemicals Alternative Committee is hoping it can provide and be that forum. So in summary, I know growing interest and demands in the use of alternative chemicals assessment. I know I get calls almost daily about this. The HESI Sustainable Alternatives Committee is formed to try to help develop that guidance. We need more help. We need more experts that can come to the table and bring their ideas to us. We need those that can help us go beyond hazard so that we can assess those things that are a bit more nebulous and difficult to compare. And it would be really good if we could leverage on what is already being done with hazard ID. As I said, there's pretty good frameworks already in place and good tools, and if we can build on that in a similar fashion for these other areas, I think that that will provide some excellent guidance and detail that's much needed as we're going forward with this. So again, greater collaboration, and we're not there yet. So still a lot of work to do and a lot of questions left unresolved. So with that, I will open it up, I guess, Jen, for any questions that might be with the audience.
Thank you, Pam. And on this slide is also my contact information. If anybody's interested in learning more about the HESI Committee on Sustainable Chemical Alternatives or has interest in joining the committee, helping out with our effort, please don't hesitate to contact me. Are there any questions for Pam? As you all think of your questions, I'll also mention that in 2 weeks.
Hello.
Hi,
Hello.
do you have a question? Yes.
This is Toshi. Can you hear me?
Yes.
Hello.
Yes, I hear you.
All right, good. It's a wonderful talk and a very exciting idea. I'm, however, wondering how we could realize this plan, and also how we can, or at least how can I help you to make a bridge to fulfill the gap between HESI activities and Japanese site. So fortunately, I have found the I was working at the weekend, so that I would be very happy to work together with you.
Okay. So Jen, it sounds like he wants to know how he can maybe get engaged in the activities. Maybe you can give him that information.
Yes,
Right.
I can give you more information, and we're definitely interested in having more Japanese perspectives in alternatives assessment. I think it's an area that's certainly of interest in growing in Japan, but maybe...
Yes, please come to Japan. And I'll be happy to organize some, session. And thereby your information, your idea, your plan should be exposed to Japanese people.
Agree, yeah. And Jen, I know that you sometimes have meetings that are targeted there. This might be an opportunity to leverage when you're doing that.
Right.
Yes. Thank you, Toshi.
Suggestions that we don't necessarily have to have questions. We would love feedback as well.
Just one quick question, okay? Hello?
Yes?
Just one quick question. Maybe I missed something, but when you think about the risk trade-off, benefit risk analysis would be one of the subjects, and those processes are already included in the process.
The benefits and risk are included. You're right. They say that you should consider the benefits and the risk. They don't really tell you how to go about doing that. So what are the important things that should be carried forward as having more weight in the assessment? Because whenever you do an assessment, there are probably always going to be some conflicting results. Maybe that, something that you do that's good for human health may end up not being so good for energy conservation, right?
Yeah. Yeah.
So how do we make those choices and weigh those attributes to say which ones should really drive the selection process?
Yeah. I just simply thinking about the cell rates as a retardant in a polymer, and maybe we have a problem with the lipid toxicity for cell rates, for example, but it's useful as a retardant for polymer, so it's kind of a benefit risk analysis.
Mm-hmm.
Yeah.
Yeah. Good point.
Yeah.
Very good.
Okay.
So maybe you could share that with us.
Other questions or comments?
Hello, this is Jen Yu from DuPont. I'm now in Shanghai, China. So I have a quick question basically on, you talked about transparent weighting. Could you explain a little bit on this? Is there any progress on, building some formats, or is there any progress on this?
I mean, there are areas that are working on it. So again, if you go and you look at the multi-criteria decision analysis, there are some papers that came out of, Jen, remind me, I think it's Berkeley, on that topic that do give some guidance on potential ways to look at it and to make those determinations. I think that they still are limited in the type of attributes that they're looking at. They're still largely looking at things like performance, human health, environmental risks, and so we really haven't got, I think, a good framework that brings all of the elements that we think would be important to consider. So there's some initial work that's been going on, and that's what we're trying to do, is to build on that.
Thank you.
So, I mean, if you're interested, we could point you to those publications, too. If you send Jen an email at her email address here, she could certainly do that.
Sure, I'll definitely send an email to Jen afterward. So I'm actually thinking, maybe we should come together, kind of as a group and, get some kind of a system, like, suggested scoring or like that kind of a system that might help to standardize the system.
Mm-hmm. Yes, good idea.
While we wait for other questions, I'll just briefly mention that the committee will be participating in the, the Green Chemistry and Engineering Conference, which is taking place in about 2 weeks in Washington, D.C. And we're also having a session at the CTAC North America meeting that's going to be held in Vancouver, Canada in November. And unfortunately, abstracts just closed for that, but if anyone is attending that meeting, I think it should be a good one with several sessions related to alternatives assessment as well as life cycle assessment. Mm-hmm. And the committee is also working on several publications, so please stay tuned for further elaboration on the topics that Pam talked about, specifically the recommendations and needs, and we have also a paper on the decision analysis component, and we're working on a web resource to describe the data gaps and identifying sources of data for filling data gaps that Pam described today. Are there additional questions? Okay. Pam, do you have any other closing comments or remarks?
No, other than, you've got Jen's email, and I've heard some, great suggestions. It would be good to connect, and we'd love to have your participation as part of this committee. So please consider reaching out to Jen at the email provided. And thank you so much for your time tonight.
Okay, thank you, everyone.